So when we look at this design here, what we've got is an input and a push button addressed to PLS M0, and that we use the F8 command to create that. And PLS is pulse. What that means is that on the rising edge of this signal, the rising edge only, then M0 will turn on, and it turns on for one PLC scan only. That's all. One PLC scan. Even if this is on for several hours, it makes no difference. It will only have turned on the rising edge of the signal. And so what we have here is normally open contact addressed to M0. So when we press that button, that pulses M0 for one scan, that turns on for one scan, which then activates the increment command, and the data register value goes from 0 to 1. You let go of this button, you press it again, and it goes to 2. Every time you press this on the transition, you get a one scan pulse here, which then increments that data register. This signal down here, push button, is directly influencing that increment command. So when it turns on, as you've seen, this goes and counts up very rapidly. 1, 2, 3, 4, 5, 6, 7. Why is it doing that? Edward, why do you think it's doing that? It's doing that because of the scan of the program. The scan comes down here, it reaches this point, and it says X2 is on. So it says, right, that's on, what have I got to do? Pulse M0. So it does that. It comes down here, it says, right, M0 is on. Increment D1. Comes down here, this is off. So it moves on. Comes back in the next scan, you've still got your finger on here. It takes 3 milliseconds to go from here and back to here again. You're still holding the press button, the push button. So it comes to here, it still says this on. So now it knows M0. It's no longer going to come on. It comes down, it says, well, that's not on. Nothing happens. And so it goes around. Eventually you take your finger off here, you put it back on again, and it sees the transition and it counts again. Next time, however, you press your finger onto this one. The scan comes down, this is not on, so nothing happens here. It comes to here, it says X3 is on. X3, normal input, then increments data register by 1. It comes in 3 milliseconds later, and it does it again. On every scan, it's incrementing all the time. What's the scan time of your program on yours?
2 milliseconds.
So you've got 2 millisecond scan time. If you click on D1 and type in Alt 1, and where you see D1, set the value to 0. So we're going to reset that. So it's there and then set 0. Yeah, and press the set button. And that resets that for us. There, we can close that. Okay, so we've got 2 millisecond scan time. Right, if you press this button here on your test rig and then let go, what's the value now?
139.
139. So 2 millisecond scan time, we've got 139. That meant that that button was then pressed for 2 times 139. So you're looking at 278 milliseconds. That's how long it was actually pressed for. It's counted that number of times inside of there. Now we sometimes use techniques. If we've got, on some processes that I've worked on, you've got limited push buttons, and the operator has to take a value for like speed control from say 0 to maybe 9,000. So he's not going to sit there pressing this all the time. Complain a bit if you had to do that. So what we do is we use these techniques inside of it, so that if he holds his finger on the speed up button for several seconds, we detect that, and then we activate this to work on the scan, and the speed then starts to ramp up. And when it gets close towards that speed, he lets go, and then he fine-tunes it in until he gets to the speed that he wants. So we can use little tricks like this using the PLC scan to work in our favour. Okay, let's go to monitor write mode on your PLC and change INC to INCP, P for Peter.
Yeah. So you've got the monitor write mode, which is that one there.
Data handling. All PLCs have data storage areas called data registers. And it's in here, there's several thousand of them available for you. You'd be surprised how many you actually use in the program. It's quite a lot. And you store in there values. The values can be anything. There could be speed settings, there could be limits, there could be counts, how many parts have passed. It's funny that because some people say, well, what do you use counters for? To count material. No, you don't. You count events for the timer, not the number of materials. So if you have bottles going down a conveyor, you don't use a counter to count how many there are. The counter is there to count the number of events, and then once those events are completed, you then enable another one. So you might use a counter to count how many bottles are passing and then stop that process and enable something else. Yeah? But if you're counting materials in production output, then you don't normally use a counter. You would normally use well, you wouldn't use a counter. In fact, you would use a data register, and you would use what we call an increment function, which will increment the value inside of the data register. We'll look at that later on.
Yeah, so at the end of the day, they can say, okay, we've done 30,000.
30,000, that's right. So, temperature and speed readings, etc., material counts, COM settings, and also other analog information. All of that is stored in data registers. There are 6,000 available altogether for your use, and they're 16-bit in length. Now, some functions, instructions inside of a PLC, when you're doing maths, will use more than one data register. We'll look at that tomorrow, because you'll be using 2 data registers for 32-bit maths. Big numbers. Typical application. This is a SCADA. This is actually an oil rig job I did a couple of years back. And these are silos. And up here, these here, that's kilograms. And that there is looking at a data register in a PLC. And the PLC program, part of it, is actually weighing the amount of material inside of that silo and displaying it up here in kilograms. And here, it's another one, and it's actually bar, BAR, and it's looking at pressure. So it's looking at the actual air pressure in the system and displaying it in this area here. And this is for every silo. And there were like 18 of these on the rig. So we're weighing the material in each of those. So all of these are data registers that are holding all of these values in here. Down here, you've got here percentage value, which shows you the it shows you the positional value of that valve as a percentage. So if it's 100%, it's 100% open. If it's 0, it's closed. And here are controls which allow you to open the valve and close it manually and see what position the valve is actually in. And all of this is being controlled and done inside of data registers. So that's what we're using data registers for. And you use thousands.